So the top, we could factor out a 3x. That leaves us with x minus 1. On the bottom, that would factor into x plus 4, x minus 3. So nothing cancels. Then we go through all of the different pieces of information. So what I have you find first. How do you find an x-intercept? Right. It's when y is 0, which is really just when the top of the fraction is 0. So I'm just trying to find when does 3x times x minus 1 equal 0? At 0 and 1, because you set each of those equal to 0. So we hit our x-axis at 2 places, 0 and 1. How do we find the y-intercept? 0 in for all of the x's. If I do that, does it matter if I use the original or the factored one? Nope, same answer. So on the original, if I put it in, I get 0 over negative 12, which is just 0. How do we find vertical asymptotes? Right, whatever's on the bottom. These are lines, so I have to have an equation. If you just tell me a number, you are going to lose a point for not writing the equation. So x plus 4, what makes that equal 0? So it will be x equals negative 4. And x minus 3, that would be x equals positive 3. How do we graph asymptotes? Okay. Alright, now we have to check if it's horizontal or oblique. And we've talked a lot about this, how it's really just like a dividing. So if we think about dividing this, can you do 3x squared divided by x squared? Yes. What does that give us? 3. So if the x cancels, that means it's just a horizontal line. So y equals a number. And this is at y equals 3. All right. So now we have to be able to get the rest of our graph. This is kind of where it's unfortunate that we can't just rely on a calculator, but that's okay. We're smart people. We can figure this out. What do we have to do? Plug in points. So we know enough about this to get an idea. We know on each side of this asymptote, it's either going to go up like that or it's going to go down like this, right? I just have to decide which side it's on. So we need a number to plug in. And let's just use our calculator to at least plug in that number. So we need something smaller than negative 4. So if I put in negative 5, what do we get out? What'd you get? Okay, if I have negative 5, 11.25, that's all the way up here. At this point, we know this one is above our horizontal asymptote, right? Now, could we get more points if we wanted to make our graph more accurate? Absolutely. What I'm looking for is, do you know what's happening? Do we know where this is? And that this is just going to be curved, getting closer to our asymptote. So something like that. And again, I knew it was up here because I plugged in an x value and I got a point. The middle section. Okay, we saw a lot of them yesterday that kind of were, going up or down. They don't have to. We talked about it and I said a lot of times they will, but it's not necessarily a rule that it has to. We already know this one hits the x-axis twice here. Let's plug in another point, because I can't just look at this and know exactly what it's doing. Can you guys? No. So let's try negative 2. So if I plug that into my equation, again, just use your calculator. You don't have to show me your work for how you're getting these. Just tell me what you're plugging in. And I get, what you guys get? step. So that's telling me it's down here. Now we know a little bit about these graphs. Can my graph just go flat between these 2 points? No, it's an x-intercept. Did they have multiplicities of 2 on these intercepts? No, they were both a multiplicity of 1. So we do know that means it's not going to bounce, right? It's going to go through them. So it's starting down here. It has to go through this point, come back and hit this one. It's not bouncing, so where's this side going to go? Back down. So it looks like that. All right, we have one more side. Let's plug in a number. We need something bigger than 3. So if I put in a 4, let's see what we get. What did you guys get? My halves are 4.5. So that's up here. So this section is also above my asymptote. So something like this. Is my graph perfect? No. Did I list out all my information, plot the intercepts, the asymptotes on my graph, and then draw in my curves? That's what I'm looking for here. All right. Questions there? Let's do the other 2 we didn't get to yesterday. So, first step is what? So factor so we can get our x-intercepts and everything. So this is x plus 4, x minus 3, or x minus 3, x plus 2. What happens? This turns into x plus 4 over x plus 2, which is what I'll need to use when I graph, but because something cancels, I know there is a hole in the graph. We need the ordered pair for that. So where do we look to find the x values? The thing that canceled, x minus 3, what makes that 0? How do we get the y? Plug it into what's left. If I put a 3 in here, we get 7 over 5. So on our graph, positive 3, 7 over 5, so like 1.4, we have an open circle. Now we're just going to keep going, but we're going to use this reduced one. So the x-intercepts, I'm looking at that final one. X-intercept is when y is 0, so really just when the top of the fraction equals 0. So we hit the x-axis, the -4. Y-intercept is when the x is 0. So if we put in 0, again, can be the original, can be the reduced one, does not matter. I get 4 over 2 or 2. Vertical asymptote. It's what makes the denominator 0. So that is x equals -2. Horizontal or oblique? How do we decide? Divide. It doesn't matter if we do the original or the reduced one. If you are doing x divided by x, what does that give you? 1. So the x's cancel, so it's a horizontal line. Y equals 1. Do I even need test points to graph this one? No, we kind of already know. The first section either has to be above or below my horizontal asymptote, but I already have a point down here, so that shows me it's below. The second one, I have points above the asymptote, so I know that's above. Why don't you guys try the last one? See how far we get. So that took a little bit longer, but we do have a 2x minus 3 that cancels. So your whole would be at 3 halves, because that's what makes 2x minus 3 equal 0. If you plug a 3 halves into what's left, what do you get out? -11. Okay. So this is going to go off my graph a little bit. So 3 halves is like 1.5. It's all the way down there. Again, I got the 3 halves by asking what makes the 2x minus 3 equal 0. And then I got the -11 by plugging 3 halves into this. X-intercept is what makes the top equal 0. And so that is -1/3, so we hit the x-axis at -1/3. Y-intercept, that's when all of our x's are 0, which you get -1/2. Vertical asymptote, x equals what makes the bottom 0? Horizontal or oblique. So we can look at your reduced or the original, either way. We have to think of it as a division problem. If we were to divide these, can you do 6x squared divided by 2x squared? What does that give you? 3. Since the x's cancel, that's y equals 3. If the top were smaller, if it had been a 6x on top, what would it have been? 0. What if it had been a 6x cubed on top? It would be oblique, and that's when you have to do long division. Okay. So we have a horizontal asymptote at 3. So we should have 2 pieces, one for each side of this vertical. The left I can kind of tell already, because I have these points. And then I have to come down and hit this hole. And get that section of my graph. Over here, we're going to have to plug something in to know if it's above or below. So if I put in, for instance, a 3. You can do the original, you can do the reduced. I'll just go with my reduced. So that gives me 10/1 or 10. So 3/10, that means this section is up here. Questions on these? So here is the game plan. The 3 2.5 handout is due tomorrow. You did 1 through 4. So now you're doing the back side. Okay? If you finish that, I do have study guides because we are at the end of chapter 3. Our study guide is going to be due tomorrow. Will just be like a work and ask question day. So I want the study guide done on Thursday. Okay, so you get a day just to work on it in class. If you have time today, you can get started on it. Thursday will be a class review day, so we are going to go over things together. And our test will be Friday. Okay, so you kind of know what's going on with the rest of it. So finish that handout.